In this video, I want to talk a little bit about even and odd functions, define them, and show how we can algebraically determine if a function is even, if it's odd, or if it's neither. So again, our definition for an even function, we have f of negative x equals f of x. In other words, if we plug in the opposite input, we get the same output. So for example, if I had f of 2 equals 7, then f of negative 2 equals 7. If I had f of negative 5 equals 13, f of positive 5 equals 13. Opposite input gives me the same output. When we're talking about an odd function, if I say f of negative x, I'm going to get the opposite, or I'm going to get a negative f of x. In other words, the opposite input gives the opposite output. So if if I had f of 2 equals 7, then f of the opposite of 2 would be the opposite of 7. F of negative 2 is negative 7. If f of 4 equals a negative 3, then f of negative 4 equals a positive 3. So again, with an odd, you put in the opposite input, you get the opposite output. Even, you put in an opposite input, you get the same output. If neither one of those works, it's not even, it's not odd. So that's kind of some working with some of the symmetry is what we're talking about here. So how do we check this out? Well, one thing, we cannot just do it the way I'm showing here by picking a number, putting in the opposite in, and see if it works, because it's possible that it might work for some values and it doesn't work for others. And we want to make sure that it's going to work for all values. So, because for example, if I had, let's draw a little quick graph here. Oh, that looks horrible, but that's okay. No, that's not. Let's just undo that. I'm too picky. What's going on here? Okay. Did I go too far? Yes, I went too far. Okay. If I had a function that worked like this, I can look at this. F of 2 equals f of negative 2, which equals 0. So if I plug in 2, negative 2, yeah, it looks even. But if I plugged in f of 4 equals 0, but f of negative 4, that's somewhere way down here, equals negative something or another. It's obviously not 0, so it fails. So we can't just check with one point. We need another way to do that. So to check, basically you can prove it's not even by picking a point. You can prove it's not odd by picking a point and show it fails. But to check that it's always true, we have to check with all values. So we're going to plug in, or we're going to find out what is f of negative x. We're going to work with that value. So again, a reminder, even f of negative x equals f of x. Odd, f of negative x equals the opposite of f of x. So let's check and say my function's going to be 4x minus 7. I'm going to check it by finding f of negative x. So I say, what's f of negative x? F of negative x is a negative 4x minus 7. And now I'm going to check. Does that equal 4x minus 7? Obviously not. Minus 7 is good. 4x does not equal negative 4x. So this is not odd, or not even. So then I check, okay, does this equal the opposite of f of x? The opposite of 4x minus 7 would be a negative 4x plus 7. So we got the negative 4x, that's good, but we got a plus 7 versus a minus 7, so it's not that way, it's not odd. So this is neither. And that makes sense, this is a line, and lines are not symmetrical with the x-axis. They can be symmetrical with the origin if they go through the origin, but otherwise, no, they're not going to be, so that's a neither. But what if we do this, the absolute value of 4x minus 7? Does that make a difference? F of negative x would be 4 times a negative x minus 7. The absolute value of a negative 4x minus 7. But again, does that equal? This obviously does not equal the absolute value of 4x minus 7, because this one inside, you don't take the absolute value until you're done. This was probably a bad example. Oh well, I'm still recording. I'm not going to start all over again. It doesn't equal the opposite. And it's almost time for lunch, huh? Of 4x minus 7. So this is neither also. Oh, let's see if we can find one that actually works. So we are going to try, what if we have f of x equals x squared minus 7? Again, we try f of the opposite of x squared minus 7. But if you take a negative number and square it, you're going to get positive. So that equals x squared minus 7. So that equals f of x. So this function is even. Makes sense. I got an x squared in it, right? What if I make this function x squared minus 7x? Then again, f of negative x equals the opposite of x squared minus 7 times the opposite of x. And that's going to equal x squared, because again, negative x squared is negative 1 squared, which is 1, times x squared. But here we get negative 7 times the negative x is a plus 7x. So again, this is not going to equal x squared minus 7x. So it's not even. And it's not going to equal the opposite of x squared minus 7x, which would be a negative x squared plus 7x. We got the plus 7x. We don't have the negative x squared, so it's not odd. So this one is neither. But now if I take this one and made that x cubed minus 7x. Again, f of negative x. We're always doing the same thing, plugging in negative x for x. We get negative x to the third power minus 7 times negative x. And negative x, a negative number to the third power is going to be a negative, so that's the opposite of x to the third power. Negative times a negative is positive, so that's plus 7x. And here we're going to see this does equal the opposite of x cubed minus 7x, which would be a negative x cubed plus 7x. So this is an example of an odd function. So let's play just a little bit with fractions here. Two x cubed over 3x squared plus 2. When I do f of negative x, 2 times a negative x to the third power over 3 times a negative x squared plus 2. Again, that's going to give me a negative 2x to the third. The negative x squared is going to be a positive, so I get 3x squared plus 2. So I have the opposite of the numerator, but not the opposite of the denominator. So what does that mean? We'll just look at what is the opposite of f of x. That's negative 1 times 2x to the third over 3x squared plus 2. And when we do this, that could be, we could put the negative on top and make the numerator negative and the denominator positive, or we could leave the numerator alone, 2x cubed, and take the opposite of the denominator. So that would be a negative 3x squared minus 2. We don't make both the numerator and the denominator negative, because then we're doing a negative over a negative 1 over negative 1 is positive 1, and we're not taking the opposite. So in this case, we see it fits with this. The numerator went negative. The denominator stayed the same. We want one of them to stay the same. So this one is odd. F of negative x equals the opposite of f of x. Now if we change this around, let's do this function. 3x squared over 2x cubed minus 4x. Again, we go f of negative x. We listen to that lovely bell. 3 times negative x squared over 2 times negative x to the third minus 4 times negative x. Again, this is going to stay positive, 3x squared. This one is going to go negative, negative x cubed minus a negative plus 4x. And that is going to equal, because this one is the opposite, this one's the same, so we have a positive over negative, so that's the opposite of 3x squared over x cubed minus 4x. Oh, I forgot the 2 on there. So this one is also going to be odd. So again, our main goal, we plug in when we're checking for even or odd, just plug in f of the opposite of x, and then take a look and see, does that equal the original function, f of x? It's even. Does it equal the opposite? It's odd. Does it equal something else? It's neither.